Hello, this is the debug lecture for Introduction to Python. Just so you know what you're looking at here, I think it's clear. On the left-hand side of the screen, I have the typical slides that are presented on the course webpage. On the right-hand side of the screen, I have my VS Code installation. I do just want to note, this is not a default VS Code installation. It's my personal install I use. So if you see some things that look a little bit different, just don't be alarmed. I won't be doing anything novel. It might just look a little different. So without further ado, let's begin. So where we're at in the semester is this lecture is slated for the Friday of the third week. What that means is that the same time this lecture goes out, we'll be posting the third problem set, which is on strings, but you don't need to worry about that yet. That's just being posted so that when you're ready for it, it's there for you. The current ongoing problem set is problem set 2 checkers, which I named after the fact that there's a checkerboard assignment, and then also you have to check things about a number, right? That is already posted. You've already been working on that. The first assignment is a Carol assignment, which was covered in the first 4 lectures, and then the last assignment was already covered in the last lecture, but we're going to be going over some techniques that will make it easier to work on that problem today. So we have the problem set 2 checkers due Monday at midnight. That's the upcoming Monday. I'm going to take a look at the calendar to see when that is. That's the 15th, right? And then the next one is due on the 22nd. All right, what are we going to do today? So today we're going to talk about the principle of debugging code. This is a really central topic to computer science. When I was just looking up descriptions for it, I often had to furnish the keyword engineering or software, but it's a computer science thing, and debugging is something you do sort of in all areas of your life. I think you also, well, I think of it this way, right? I debug recipes that I read and follow online, or I don't think the timing quite works out, right? I might have to do it more than once and take some notes and come to some assessment of the order in which I boil my potatoes and bake my tofu, which is, just something I do. So debugging is a conceptually high-level framework. It's part of the science of solving problems. If we think of computer science as a science of solving problems, we can also apply the formulation of debugging to computer programs, and this is perhaps where it's most commonly used. And it is oriented around this idea of a bug, which is a part of a piece of software, a program, or in our case, just a little bit of code you wrote that doesn't do what you want it to. Now, the computers will always do what we tell them to do, but we don't always say what we mean. And so we're going to work on taking out the parts of code that don't do what we want them to do. And that's what we're going to work on today. One of the ideas that was called out specifically in one of those definitions, and I lifted those definitions just from Wikipedia, one of the things that was specifically called out is the principle of control flow analysis. In this class, I've used the term control flow to refer specifically to the usage of these 4 keywords in Python: def, for, if, and while. And so that's functions, conditionals, and then the 2 loops, the for loop and the while loop. Why do we call these control flow? They deviate from sort of the standard practice of code, where execution proceeds from the top of the document to the bottom of the document, executing one line of code at a time. And that is how programs run unless there is one of these statements. If there's a def statement, we might go to wherever that function is defined and execute those lines of code. If there's an if statement, we may or may not execute the next indented lines of code based on some condition. And with both for loops and while loops, there will be some indented block of code that may be executed 0, 1, or more times. So that is a change to how control, which is just what you're doing, flows, which is what line you read next, through a program. So control flow analysis is what we're going to work on today. And I'm going to use a running example. This running example is inspired by the homework, but it could be inspired by anything else. And I'm just going to do the example of finding the divisors of some number. It is motivated by my interest in cryptographic research and systems and things of that nature, specifically RSA cryptography, which is one of my favorite things to think about and teach. Usually comes up as an enrichment topic in CS1, but it's the basis of much of modern web security. And so it is interesting, and it is a valid application of computing to think about how we can find the divisors of numbers. And the divisors of numbers are the values that are smaller than that number that divide it evenly. So the divisors of 6 are 2 and 3, because 6 can evenly be divided by 2 and 3, but it cannot evenly be divided by 4, for example. So I'm going to take this running example and I'm going to set it up in VS Code on the right side of my screen. In order to do that, I'm going to use the Control-N keybind to create a new file. I am going to save this file as debug.py, because that is the name of today's lecture. And then I am going to copy-paste over the code from our lecture, and I would encourage you to follow along with doing this as well. Just something to point out, my screen here is wrapping at 80 characters, so that's a bit long. I'm going to trim this comment here just a little bit so it fits on one line. There we go. So what's going on here? Well, I'm going to name some indented code. So there will be code written here where this current comment is. It says, we'll print the divisors here. So there's going to be some print statements here, perhaps there'll be some other elements of control flow. And then the last thing I'm going to do is return the number of divisors here. This is inspired by the divisible by 6 or 7 homework assignment, where you print some things out and you return something else. I wasn't that clever and I didn't think of necessarily other things to print or return, so we're just going to follow through with that example. One thing I want to point out here is this use of the return statement. This is already going to alter a little bit how this function works versus some Carol functions. And this value here it is what's called a placeholder value. It's just to denote that I'm going to at some point have some number there, but I haven't actually calculated if that 0 is correct. So, excuse me, there are no numbers that have no divisors, though there are numbers that don't have divisors other than one of themselves. Those are called the prime numbers. They exist. They're interesting mathematically and for cryptography. And so we're just going to return some number, but we're going to check to see what that number is. So I just have that code there for now. So let's take a look at the idea of this problem. So say we want to print out and I'll call them values. We want to print out the values that evenly divide n, and then we want to return how many values we printed. Okay, why might we want to do that? Well, maybe we want to see the values to provide them to a report to ourselves or a cryptography researcher, and separately we want to be able to check to see if there's a non-zero number of values, right? So we might want to check to see if 0 is being returned. So here's a possible sketch of how we can decompose this problem. We probably need to have some way to check if some value, which we'll call x, divides our input value, which we call n. So this is a way to tell if some number is possibly a divisor of n. Separately, we also need to know what values we should check to see if they're the divisors. And then finally, we need some way to count how many divisors we have found. And so I'm going to do each one of those things separately. I'm sorry, I'm going to cough again. So the way I'm going to decompose this, and actually let's go back just one step. Each one of these can correspond to perhaps a different function or perhaps some other control flow statement. For the first one, how do we know if some x, some numerical value, divides another numerical value n? We can express that with a function. So we're going to grab this function, and this function is going to come with a return statement. Now, I'm just going to call that a placeholder. At this point in time, I'm going to go ahead and run this code. I've included sort of quite a few lines, and I need to make sure it's working. So let's go ahead and run that. I used Control R to do that because I have it set up. You might also have the play button up here if you have the VS Code Python installation, as I expect you do. This is unremarkable. Nothing happens. I don't have any print statements. I don't expect to see anything. But nevertheless, it's nice to know I don't have any typos. This is actually Python. And let me show you one thing that could have happened. Absent this placeholder, I'm going to go ahead and get rid of this. Absent the placeholder, I get an indentation error because I have a control flow statement, the def keyword, where I provide the name of a function, the possible arguments for a function included in parentheses and separated by commas, and a colon. And if I have all of that, Python expects there to be something on the next line. One of the things that can be on the next line is not having any return value at all. There are other things we can put here. For example, we can say 1 equals 1, which is just a meaningless statement, just something to have some text there. We can put a string. That still works. And by convention, the most common thing to put is pass, which doesn't really mean anything. It just means nothing's going on. Just to look at this again, this is what we see if there's no indentation errors. I'm going to put the colon back. And this is what we see if there are indentation errors. So I expect new programmers to at some point in time see this because, oh, you're partway through writing some code, or you started writing a function and then you didn't come back to it. This is the error, and the way to solve this error is you can either comment out this line, and then the problem goes away, or you can add anything at all to the contents of this function, and my preference is to return none, because I haven't written a function yet, right? So it currently does nothing. You can also perhaps return false, though that might be meaningful, right? I'm just going to expressly not return anything at all. I would recommend, when you're writing functions, always have the first thing you write be a return statement, and specify if you mean to return something or nothing. It is well-formed Python, and I'll demonstrate this, to just say return, and this does the exact same thing, which we can demonstrate. Oops. Print x divides n 7, 5. This is already returning none, and if I specify none, so there's an implied none here. Once again, I see the none. Specifying the none there indicates that you have thought about whether you intend to have your function return something or not return something, which we can think of, what do you want the function to look like when we print it, right? That's one way to think about it. So I'm recommending when you start writing a function, always begin with this formulation, and then just change it later if it doesn't serve you, okay? Let's go ahead and get rid of this line of code. And I'm going to clean up some of these comments just to have less clutter on my screen, because I do have the comments on the slides. Okay, so let's continue. When I am working on writing code, oftentimes I will use the print statement prolifically. I will use many print statements. I will write specific print statements. I will include helpful comments to myself, such as what line I'm writing them in. Excuse me. And let's give an example here. At the beginning of these functions, another thing that might be helpful to write is I can say the name of the function and the arguments, or provided values to the function, the parameters, the inputs, whatever you want to say. So I'm going to go ahead and write that out. I'm going to take a sip of water. I'm going to say visors with n equal, I'm going to say n. So this will print this string, then this value. Down here I will say print x divides n with x, n equals, and I'll say x. I'm using slightly different formatting over here. This is intentional. I want to show you there's different ways you can write these things out. Let's go ahead and take a look at this example. What does this do? Well, right now it doesn't do anything because I'm not calling the functions, I'm only defining the functions, but that means there's no clear errors or no clear deviations from Python standards here. Let's just start with an example of what we're going to do, which, let's look at the divisors of 6. And then what do we see? We see divisors with n equals 6. That is what we expect to see, because we expect this divisors to be replaced with this code right here. So we expect to see the same thing as if we do this, because that is how the control was intended to flow. But n is not defined, and that's because n was supposed to be 6, and so there we see the same thing. And I'm going to change this back to divisors of 6. There's one other thing we might want to check. We might want to print divisors of 6, which will enable us to see the return value of divisors of 6. And when we do that, I expect it to be 0, because I expect this value to be replaced with the return value. So let's go ahead and check that. I'll leave this up, and I expect to see a 0 there. And there's my 0. So we see what is printed, and then this becomes the value of the return statement. Confusingly, and I understand this is strange, we are also printing the return value, but we are printing it outside of divisors. Let's take a look at one more example. By removing this print statement, we will only see the 0. And there we have it. We only see the 0 after the big chunk of VS Code text, right? And we can start it again and see we just see that 0. Okay, so this is one way to systematically approach the problem and begin to get started. Something I often hear from students is, I don't know how to get started. I think that's easier to say than it is to argue that it's definitely true, because you can always write out the function definition, write return none, write this print statement, and then think about what you should do next. All of what I've done here so far, and you could argue this required some level of thought, but you can kind of put anything that might be useful there. You can do this without understanding or thinking about or even considering how you're ultimately going to solve the problem, but it gets code down on the page that you can start working with and start experimenting with, right? So I hope this helps you avoid having blank code documents you're looking at. And you can run this code. It just does what it says instead of what we intended to do. Let's go on to the next slide. So this is the demonstration I have just shown. Now, I'm going to introduce one additional way of thinking about things. Excuse me. The intended use of this, thinking back, is that divisors is supposed to print the divisors, and then it is supposed to return the count of divisors. X divides n is supposed to return whether x, I guess I'll say divides n, and we'll decide what divides n means later. So I think that is n is, or yeah, x is a divisor. So what can we do with this? Well, we have a little bit of problem where I'm printing something that is useful to me, but I'm expected to not print anything because the requirements are to print the divisors. So what we're doing right now is we're engaging in the act of debugging. And so I'm going to create a variable called debugging that signifies whether my code is being used for debugging or whether it is ready to turn in and finished and complete. And I'm going to do that by creating a variable named debugging and setting it equal to true. Close this. Debugging equals true. I'm going to use capital T, but if I forgot and then ran this, I would be instructed to use capital T. And then it runs without error. Now, I only want to see these print statements while I'm debugging, so I'm going to add if statements. Now, when I added that if statement, I wrote a control flow keyword. This is just checking to see if debugging is true or false, right? That is the same as saying if true or if false, right? And this is a colon. Now, when I wrote a control flow statement such as this, I should always indent the next line. That's why I'm getting these red squiggles under print. If I don't, what happens? I get an indentation error, right? expected an indented block after if statement on line 3. This is line 3. This is after line 3. I will indent that one time. All of the errors will go away. I will run my code again, and now it will run without error. I'm also going to add this if debugging formulation to x divides n. And I will run that again. Oops. Oh, something's going wrong. There we go. And we see the exact same thing. So this is a nice way to set up your code so that it can have debugging or not. And by debugging, I mean print statements that are useful to you. I'm going to change this to false, and we're going to look at what happens. Changed it to false, and we see we're only seeing this print statement, the 0. And in fact, if I get rid of this print statement, we won't see anything at all. So this is a way to have print statements that you can see. You can set this to false before turning in the code, and have code that only prints what the assignment asks for, while you can still fix it easily if something goes wrong with it. So I wanted to show you this technology. I'm also going to show you a little trick. This is something of an advanced topic, but I think it's really cool, and I wished people had shown it to me, so I'm going to show it to you. In Python, it is possible to use something called short-circuiting, and short-circuiting is used over specifically and or. And or are two Boolean operators, so I can print true and false, and I can print true or false. And I can look at that example and I see false and true. Now, when it comes to what short-circuiting means, one way to think of this is that a true statement can only be true, or an and statement can only be true if both sides are true. What this means is Python checks the first thing, and it will only check the second thing if the first thing is true. So I can put some code here. And this code will only be evaluated if the first part is true. I'm going to delete this line. I'm going to delete this print statement. I'm just going to say true and print some code. And I'm going to see some code. Why? Because this side is true. It is possible this whole statement is true because this side is true. So Python will evaluate this side. Okay? I can put other things here. If I put false here, then what happened? No code popped up. I'll show it again here. We'll start this. I'm going to run again. Nothing popped up. And that's because once Python sees this as false, it doesn't matter what's on the other side of the and statement. It can't possibly be true. So this print statement is not looked at by Python. It is not perceived. It is not observed. We can do this same thing with debugging. So while debugging is false, I do not print some code. And then while debugging is true, I do print some code. So I'm going to reformulate these if statements into short-circuited statements as follows. And this gets them helpfully, or perhaps not helpfully, depending on what you think, onto a single line. Okay? Oh, I have to say debugging end print. That doesn't fit on one line. Just gotta shorten the name. Excuse me. Okay, so let's go ahead and check this again. We'll say divisors of 6, and we will clear that and then run our code. And what do we see? Divisors with n equals 6. Great. This is the same example I showed you. This is editing things over to be much the same. Okay? Now, the next thing to do is to recall from the recall from the arithmetic lecture ways to tell if numbers divide one another. And a straightforward way to do that is the remainder, or it's also called modulo operator. What does this do? Well, We can remember, or we can just check it. So I'm going to say debugging and print. Oops, I'm typing something by accident. Quote, x% n is, and I will say that is the remainder. I'm going to call it the remainder. We can see if we believe me that it's the remainder. Equals x% n. Okay. Well, there we go. And I'm going to now test x divides n. So how am I going to do that? I'm going to give it 3, 10, and 3 and 9. So I'm going to get rid of this line because it's not serving me right now. And I'm going to check x divides x, I called it div n of 3 and 10. I'm going to check x div n of 3 and 9. Now, I should decide what I think both of these values are going to be, okay? So when I think, I'm going to put 3 and 10 in here, and 3 and 9 in here. So 3, when divided by 10, 3 can't be divided by 10, because 3 is smaller than 10, so I expect the remainder to be 3. And when I divide 3 by 9, I expect the remainder to be 3. So I expect this to be 3, and I expect that to be 3. Okay? Let's see if that's correct. Those are both 3. Now, that should seem not particularly useful to us because we're trying to see if x divides n. So really we need to see if 10 is divisible by 3, which means we need to change the order of these values in this expression. Test every line. I think this is an obvious mistake to make. I made it naturally when I was preparing the slides. It was a helpful mistake to make because it makes sense to make this error. But if we want to see if x is a divisor of n, we must divide n by x. If we want to see if 3 is a divisor of 10, if there's something by which we can multiply 3 to get 10, we must divide 10 by 3. Why do we do this? Because it's useful in cryptography for online banking, right? And we can spend as much or as little time talking about cryptography as we want. This is a real thing people have to check for, so it is a reasonable example to use to teach debugging. I'm going to go ahead and run this code again, and we're going to see what's going to happen. This is what it looked like last time. Now we are seeing that we have a 1 when we check to see if 3 is a divisor of 10, and we have a 0 when we check to see if 3 is a divisor of 9. Now, we know, or perhaps know, or we can find out, right, that 3 is a divisor of 9. 3 times 3 is equal to 9. There is no whole number by which we may multiply 3 to get 10. So, when x% n is 0, that means we have a divisor. So, that sort of answers this x divides n problem for us right here, and we can finish it out. Let's take a look at how we do it in the slides to just be consistent. We're able to get the 0, and from there, we can return whether x divides n in a variety of ways. Let's look at perhaps one of the most obvious ways. We will say if remainder is equal to 0, I'm going to do a colon at the end of my if statement. This if statement is something that will be true or false because I use double equals equality to compare a variable to a numerical value, right? So this will have a numerical value, this will have a numerical value. We are checking to see if they are equal. If they are equal, we can return true. And if they are not equal, so otherwise, we can return false. In order to make this a little more exciting, I'm going to print the return value of both of these. So I'm going to print x div n print. Oh, I could have copy pasted there. Okay. So I'm going to close the terminal. What do I expect to happen here? I'm going to create a hypothesis. I'm going to take 3 and 10. The 3 is going to become x, and the 10 is going to become n. That means that this n will be equal to this n, so that will be 10, and this will be 3. 10% 3 is the remainder of 10 when divided by 3. 10 divided by 3 is 3.1 or something, right? So there is going to be some non-zero remainder. That means that if the remainder is equal to 0, it's not. So I will do otherwise, and I will return false. So I expect this to return false. And then for the same reason, I expect this to return true. I'm going to make my hypothesis, and then I'm going to conduct the experiment. False and true. Now, this code is technically correct, which is the second best kind of correct after completely correct. So I'm calling this logically correct or technically correct, but this code is, we'll say, not graceful. It is inelegant because it contains many more lines than are helpful. The fact of the matter is, what this is saying is, if true, return true, else false, or if false, return false. So these lines here do not make programming sense, right? Like, they're logically correct. But because this value is either true or false, and it is the value we intend to return, we don't need these additional lines. And let me demonstrate this to you. I'm going to change this to a return statement, and I'm going to remove these lines. So I'm going to return the value of whether the remainder is equal to 0, okay? And we're going to see if we still get back false and true. So remember what this looks like. Remember what this looks like. False, true, 10, 1, 9, 0. Just looking at the end, we're doing x divides n. Okay, false, true. And we will run it again. False, true, 10, 9. We get these same results without the additional if statement. One of the benefits of having fewer lines of code is there's fewer places you can make mistakes. It would, in fact, even be possible. Watch this. Remainder is equal to n% x. So I can simply say this and get rid of all of these, and I can get the same value. So it is relatively simple to write a is x a divisor of n function. It is n% x double equals equality 0. We're seeing if there's no remainder when n is divided by x. Okay? Let's continue. This is what I just said. This is what we fixed earlier. We were doing nx. Okay. Now we have solved the first one of our subproblems. How do we know if some x divides n? Problem solved. And perhaps now that we've seen this, maybe we don't even want a separate function for it, right? But we were able to test it and learn some things about the function anyways, so perhaps that is helpful. Now we ask the next question. How do we know which x or x values or which numbers to check? As a rule, 1 is always fine. I'm going to put some 1s here. 1 divides everything, right? And then everything is also divisible by itself. So I'm just not going to check those things. Separately, every number that divides some value x has to be smaller than x, right? For you to be able to multiply a whole number times some other number, some value, in order to get x, those numbers all have to be smaller, because when we multiply things together, they get bigger. So we're going to need something that is between 1 and n. And if we are between 1 and n, we can express that with a range, okay? And this is the same range as we learned about last time. We may remember some of them. I'm going to write a quick example. For I in range 5, 10, print I. I'm going to run this code. It's going to print 5, 6, 7, 8, and 9. It is going to start at 5 and stop before it gets to 10. Now, if I want to start at 2 and stop before I get to some n value, I can express this fairly simply as a for loop. For I in range to n. And why don't I just print I here, debugging and print I, and let's go ahead and check. We'll check the divisors of 6. I'm going to run this code, and we're going to see what happens. Excuse me. So here are some values that are smaller than 6 and not 1. 2, 3, 4, 5. In fact, it's all of the numbers that are smaller than 6 and larger than 1, right? Because that's what this for loop means. These are, I believe, precisely the x values we want to check to see if 6 is divisible by those values. So let's take a look at how we do that here. We're going to use a range, and we can use a for x in range 1n, which is the same thing I have here. I guess I started at 2. And from there, we can check inside of this loop one other thing. We can check to see if x divides n, and our n value is sort of the one we got provided by up here, right? And our x value is I. So I'm going to do I comma n, and perhaps it makes more sense to call this x, and this x, and this x, because that's how we refer to the value here, okay? So I'm going to go ahead and run this code, and let's take a look at what it does. I'm going to make this larger, because I'm expecting there to be quite a bit of text, okay? So what do we have? Oh, I'm just going to move this almost all the way up, right? Okay, I'm checking divisors with n equals 6, okay? And then the first thing I'm going to print is 2. Where am I printing 2? Oh, I should have said what that is. Looping with x equals x, okay? Okay, so I'm in divisors with an n value of 6. I am looping with x equals 2, and I'm checking to see that x divided by, or let's see, x divided by, x divisible, divisor of n, there we go, divisor of n. I'm checking to see if 2 is a divisor of 6. I am looping over 3. I am checking to see if 3 is a divisor of 6. I am looping over 4. I am checking to see if 4 is a divisor of 6, and 5 is a divisor of 6. Okay, not too exciting. One thing I'm not doing here yet is I'm not printing what is and isn't a divisor. So I still need to do that somehow. So how am I going to do that? Well, I can check to see if x is a divisor of n. I'm going to put a comment here. Say x is a divisor of n, or x divides n, because I have to remember what to say there. I wrote an if statement. I wrote something that is true or false, because this is true or false, because the double equals equality will return a value that is true or false. I'm going to do a colon, and then I'm going to go to a new line, and I will be indented, okay? And then from here, the only requirement for this assignment was to print the values that divide. And so that is x, because x divides n, or x is a divisor of n. So I will print that out. Let's go ahead and run this code and see what happens, because I've changed some lines. I should make sure it works. This does happen to work. That's very exciting. But I have a lot of extra text here, so what I'm going to do quickly is I'm just going to change debugging to false. And I'm going to see I am only printing the divisors. But if I change debugging back to true, I can make sure my code is working the way it intends. Given a 6, I check to see if I have what the divisors of 6 are. I enter a for loop. I loop over x equals 2, 3, 4, and 5, which is what I expect to loop over. And then I check to see if x divides n for each of those. I check to see if 2 divides x, or 2 divides 6. I check to see if 3 divides 6. I check to see if 4 divides 6. And I check to see if 5 divides by 6. If it does divide, then I print the value. Okay? And so this is a way to understand what my code is doing. Over here in this example, I accidentally didn't exclude 1. We can take a look at that, and then we print the 1. and we can change it back and forth by editing the beginning of the range. I think you can start with 0, and then I think you might get a divide by 0 error. So be careful with your zeros. Why is that? Put a 0 here. That 0 is going to be this x. That 0 is going to be this x. That x is going to be this x. That x is going to be this x. That x is going to be this x. And divided by 0, that is a divide by 0 error right here in this line, as anticipated. Okay? We'll go back to 2. And then the code works amicably or correctly, or it does very close to what I intend. Now, we're doing pretty well, I think. I want to point out you can also do a short circuit here. I think short circuiting is cool. I think it's also confusing, but it's so cool I'm showing it to you anyways. Sometimes you just got to do things because you think they're cool and fun. So that still works. And I don't know. I think it's cool, so I'm showing it to you. Okay. Now, we can turn debugging on and off, but there's one additional thing I'm going to do. I'm also going to check to see what sort of the return value of the divisors is. So we're also going to say count equals, I'll spell out count. And then I'll say count of divisors 6 is count. This count refers to that count. I'm not getting highlighting here. There's a reason for that. These are two different Python ideas, and they're not separated by a comma, which they need to be. When I put the comma there, the highlighting is correct. Because that was a mistake I made, it's likely that it's a mistake that someone else can make, so I'm going to show you what happens when we do this. We get an error, invalid syntax, perhaps you forgot a comma. I did forget a comma. I can put the comma right here, or I can start with this and then try and add things to it. For example, I can say print count based on the next line, and that is one way to fix it. But we can also just put this on one line with a comma. And there we have it. The count of divisor 6 is 0. That's wrong. There are two divisors. We saw both of them. So someone has to do something about that, right? Excuse me. I'm going to take another drink. I think, and I was right last year, the most common mistake on problem set 2 will be students not including return statements. I don't know how to make the instructions more clear. I do think it is true that keeping clear in our minds as beginning programmers the difference between print and return, it's just weird. It's weird that sometimes things are values, and it's weird that sometimes they show up in the terminal, because the only way we ever look at values is if they're in the terminal, right? The point of this assignment is just kind of think about it. Like, I think the most pernicious error I saw in CS1 was my first semester I taught it, many years ago now. Students reported to me they spent 8 hours stuck on a particular thing on the last project. And the thing they were stuck on is they didn't have a return statement in one of their functions of perhaps a dozen lines or something. Apparently they hadn't checked to see if it had a return statement, right? I was not as explicit that year about adding return statements. I wasn't as explicit about saying, hey, when you create a function, write return none and then change it later as soon as you know it should be there. So what was happening is essentially they were opening a file and reading the file and doing a ton of work to the file and figuring out things about the file, and then not returning anything. Instead, they were returning none, and they were saving none in a variable and then trying to do operations over that none. And the code was breaking, and then they couldn't figure out why. They couldn't figure out why because they were used to printing instead of returning. We just have to practice using both, inventing reasons to use both, and then over time, as we get to the more sophisticated projects, it will be obvious why we should use one or the other. Okay, so I'm going to modify my code so that it doesn't just return 0 here. It returns the count of values that are, divisible. So how am I going to do this? Well, there's a couple different ways to do this. I think I got to get rid of short circuiting because really what I want to do is print x and then also increase a count at the same time. Okay? So how are we going to do this? Well, there's something we have to do if x divides by n. So we'll go back to it. Okay. Now, somehow I have to keep track of how many things have gone on or what's gone on. This is a trick that seems really to seem non-obvious to a lot of people. I've been working on, my partner needed to learn some Python for some of her work. She's a materials scientist, and this was non-obvious to her when she started doing loops. When we're working through things in a loop, oftentimes we want to keep track of how much work we've done, or how much work we have left, or what's going on. And the only way to do that is to set up something outside of the loop, or before we begin the loop, and then to look back at it after we're done with the loop. I'm going to just break this up with new lines so we can see what's going on. Something is going to happen in this loop some numbers of times, which is that some number of times we're going to print x, and we need to keep track of the number of times we printed x somehow. But every time we go in this loop, the only thing we're doing is we're looking at a different x value and a different n value. There's nowhere we can really write down what's going on. Now it's true we could print 1 some large number of times, right? But the code or the things we print out, the words we print out, we can't really read those back as the computer gracefully, right? So we're going to need to keep track of this some other way. And in this course, when we've been keeping track of things some other way, we've been using variables. So what I'm going to do is I'm going to create a variable outside of the loop. And I'm going to call it also count. I'm going to create a counter. And what am I going to set this counter to? Well, I want to count up how many divisors there are. So I'm going to set it equal to 0, because before I find any divisors, before I go through the loop, I don't know if there's any divisors, right? This 0 is the same 0 down here. So let's go ahead and just update this, and we'll run the code as is, and we'll see we're still getting the same 0. But I can do something with this count that I can't do with just a regular 0. And what I can do is I can change that value, right? It is a variable. It is allowed to vary. I can change the value of it. So each time I find that some x is a divisor of n, that means that I found one more divisor than I had previously. So I can say count equals count plus 1, and I believe we also noted in class you can say plus equals 1, and whichever one of these things sketches you out the least is fine. It is inherently weird to say, oh, the value of count is equal to 1 more than the count. The way this kind of makes sense is these refer to different points in time, right? Really what this is saying is when line 12 finishes, count will have a value 1 higher than it did when line 12 starts. So the count here will be 1 less. And, you know, we can actually demonstrate that. Count before. Count. Oops. Debugging and count after count. Sure. I don't know what I typed there. Debugging and count. We're just going to call this fore and aft, so if it's in, it'll be like a vote. The beginning of the vote and the end of the vote. I'm going to go ahead and run this. A lot of text there, no problem. Let's get rid of a few things. Count 4, 0, 1, 1, 2. The count of the divisors is 2. This is how I perform debugging. There's other ways. This is how I do it. So we'll see this is pretty close to what I did in the running example. I've removed many of the print statements and so on. I've tested everything. We can test this on 4 as well as 6. The only divisor of 4 is 2. It's not divisible by 1. It's not divisible by 3. Or it is divisible by 1, but that's not relevant, right? So let's go ahead and set debug false. And let's see if this does what it's supposed to do. It prints out 2, which is all the divisors of 4, and it says the count is 1. If I do this with 6, I'll see 2 and 3, and the count is 2. And if I do this with 12, what do I expect to see? 3, 4, and 6, I think. So I think I'll see 3, 4, 6. I think that's all. Is that right? Oh, 2, 3, 4, 6, right? And so then I'll see 4. 2, 3, 4, 6, 4. What are the visitors of 15? I think just 3 and 5. So 3, 5, 2. 3, 5, 2. Visitors of 18. At least 2 and 9. 2 and 9 and 3 and 6, I think. So 4, 2, 9, or 2, 3, 6, 9, 4. 2, 3, 6, 9, 4. Right. And so this does basically what I expect it to do. This is hard to read. That's kind of annoying. Let me make life a little bit easier on us. I'm going to change debugging back to true. And I'm going to bring all of my debug statements back. This is too much text. There's no way you can read this, right? But we can make things a little easier on ourselves. And the way we're going to do that is by saying divisor. So what I said, divisor, yep. And I'm just going to prefix all of my debug statements with the name of the function. Excuse me. X div. It looks like I put some effort into making sure the function names were the same length. There we go. And this is what is often called a debug trace. This is everything the program does. So if I am confused about something, this is a way to see what is happening. And then lastly, I can always just set, oh, my screen's tearing there. Do you see that? Oh, because this is too long. Okay, fair enough. And if I set debugging to false, last false, and then run the code, it will behave exactly as expected. Okay? And that's all we did today. That's debugging. That's the debugging lecture. I am providing this code to you. This is the same code I have written over here with debug statements removed. Let me show you. Remove. 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 Count. Count. For. If. Print x. Oh, I don't know why that's there. Print x, count equals count plus 1, count equals count plus 1, return count. Oh, the only thing I did is I got rid of x divided by n because that is the same thing as this. And that still works the same way, which means we can get rid of that. And there we have it. This is what we did today. Debugging is now false because we're done with the debug lecture. This is a little tease for you. You can look at this code and see what it does, but you'll notice I'm multiplying something times a space. I think it would be fun for you to debug this and see what you think it does, and see if perhaps you think it's useful on problem set 3. Okay, so we're pretty much at time for this lecture, so I'm going to say good job, thank you for your participation, pause, rewind, go back, ask questions, whatever works for you. This is how I write code. Other people write code other ways. This is my preferred way to do it. I've never encountered a problem that you can't solve by doing this. Excuse me, you have to be a little creative, and I understand that. You sort of can't force creativity. So if you need to be creative, take a walk or something, right? But if you're stuck and you don't know why your code doesn't work, throw print statements at it. Just put them in between every line, print out the values of every variables, write notes to yourself, right? Document, right? After this is done, when I hit pause on this recording, I'm going to update the website so it will have problem set 3 on it. You are under no obligation or even being strongly encouraged to start problem set 3 yet, but it's there for you and you can look at it when you're ready. And this little snippet is enough of a hint that you can do it if you figure out what that snippet does, right? So that's it for week 3. I look forward to getting back into things. In week 4, we'll be talking about strings, by which we mean strings of characters, so strings of ABCs or 1, 2, 3s, right? So a bunch of them in order. and that's going to build us up towards Wordle, because a word is a string of characters, right? My first Wordle guess every day is Aegis, and that is the string AEGIS, right? So, thank you so much, and have a great Friday and week.